And now, what will be our simplex algorithm? Find a BFS. From the BFS, find a direction, an edge to move. What is going to be an edge? You kick out a variable, include another variable. Right? There are two BFSs. You have to have an exchange of a vertex, of a variable there. So now, your simplex algorithm is slightly more concrete. Again, how will I start with the BFS? I don't know yet. We will worry about it. But then, if not optimal, find a variable to include. And I haven't shown it, but you can show that if two vertices are connected by an edge, only one variable is going to be replaced. One will enter, one will leave. Okay, so that's not very difficult. At most, yeah. So one variable. So find a variable to include. Find a variable to remove. We have another BFS, right? Yeah, so good question. There is something which we call degenerate solutions. So what I have shown to you, that a BFS corresponds to a vertex. It can happen that multiple BFSs correspond to a vertex. So the number of vertices need not be n-chosen. And that leads to some details I will shortly talk about, but it's a technical issue. Yeah, so it is not exactly n-chosen. Number of vertices are not n-chosen. Okay. So great. Again, remember, we wanted to do simplex algorithm. We had an idea. We did a bit of research. Our algorithm became more concrete. But now we want to make this more concrete. So we will do a bit of more research, more math, which will help us make this more concrete. Okay? And the thing which I am going to do is very, very simple. Take an example and try to do this. And this will give us an idea of how to formalize simplex algorithm. Let's take this example, and please don't solve it using graphical approach. Okay. Cool. This is the program I want to solve, right? The first thing is to make it into the standard program. Yes. And how do we do that? Slack variables, right? We want to make these equality. So yeah, this will unnecessarily create trouble, so let's keep it as max. But you can do with min, but I'll have to put whole bunch of negative signs, which I'm not a fan of. So I will just write it. Right? In this case, we are really lucky. We have a BFS. Can you see the BFS? If you see the BFS, don't shout. Write in your copy. What is m here? 2. That means I want just 2 variables which are non-zero, rest everything should be 0. So in this case, easy to find the starting BFS. That will not always be the case. This is going to be a big step, but at least in this case, we can start. How many people see the BFS? Raise your hands if you see the BFS. Yes, yes. Okay, good. So the BFS is x3 equal to 2, x4 equal to 1, rest I don't care, right? x3 equal to x4 equal to 1. These are my non-basic, these are my basic. And now, if you remember the last quiz question, can I express this thing just in terms of basic variables and non-basic variables? You remember how we did the last question? Last question, we had leading variables, free variables. And since every leading variable can be written in terms of free variables, we just removed it. It's the same thing. That intuition is now going to help us, that solutions of Ax equal to b. I can write x3 as 2 minus x1 minus x2. I can write x4 as 1 minus x1 plus x2. I am saying again, what I am going to do is write my optimization function in terms of non-basic variables. Oh yeah, great. But okay, yeah, okay. This is in this case this is super easy. But okay, let's. But we will have to do it so as to find out what is the value there. What is the value of this solution? The value of this solution is 0 here, right? But then I can write two. Can you help me out? X4 is greater than equal to 0, right? So why am I writing this in terms of non-basic variables? Because now it will help me find a variable such that my value can increase. I know that x1 and x2 are positive. I can bring them down. Oh sorry, I want to maximize, yes. So now if I, what can I do? I can decrease x1, increase x2. What should I do? So now x1 will be my variable which I want to include. But when I take x1, when I increase x1 from 0, I have to make sure these should not become less than equal to 0. So this will tell me how far I have to move on the edge when I encounter a vertex. Okay, so x1 and x2 were 0. I can't increase x2. I want to increase x1. This is the improvement direction. But if I increase x1, I can increase x1 only up to 1. Oh, because of this, right? After that, this will become negative. So I will keep this here. What will be my next BFS? Now x3 and what is the other variable now? x1. x2 and x4 are non-basic. Correct? What is the value of new value of x3? 1. What is the new value of x1? Right? And this fact that I could now write everything, now I can write x1 and x3 in terms of non-basic variables. That happens because so again, what am I going to do? I am going to write my objective function in terms of non-basic variables. That means I am going to express this, right? x3 equal to this, x4 equal to this. I want to change it so that I write it in terms of x3 and x1. So I will have x3 and x1 in terms of x2 and x4. And that will just be done by replacing everywhere x1 in terms of x4 and x2. Right? But this fact that you can always write your basic variables in terms of non-basic variables should be obvious to you. This should not come as a surprise. It's not this example where I am able to do it.
The basic variables are like the pivots.
Are the?
Pivots.
Yes, exactly. I know this, right? I know. What did it do? XB in terms of non-basic variables. Sorry, it should be. So implicitly, I know that expression has to be possible. I am just doing it in an easy way. Right? So can you write now what is x3 and what is x1?
X1 is x2 plus x4.
x2
Minus x4.
now in x3 minus you guys have pen and paper, can you tell me what to write here? See, if you help me out, you go home early. I don't know why you are resistant to helping me out.
Plus that's it. Plus
2 minus 2 x2, that's all. Oh, there is no x1, x4, no x4. Okay, and what am I maximizing? Plus, minus. I have to look at my calculations. Oh my God.
x4.
1 minus 2 x2 plus x4. Okay, great. Now I have this as my BFS. The solution, the value at this point is 2. I got an advantage, right? My optimal value increased. I am maximizing. I got to 2 from 0. Right? This is my set of conditions. Now I can put x2 in my BFS. How much x2 can I put in my BFS? That will be determined by half. Good. So now my BFS would be, yeah, so x2 is half, x1 is, okay, and x3 equal to 0, x4 equal to 0, sorry, x1 is 3 by 2. Okay, and then see, because you guys are not doing this in exam, I will give you a simplex algorithm to simulate. That's the only way, because it's clear that you can't do this simple equation substitution. One will say 1, one will say 3 by 2. The only way to ensure you can do it is to give it as a question in exam, and then you will simulate for half an hour this entire thing. Okay. Okay, so now let me do this thing. Ananya, tell me what will come here. Maximize. First equation, so this should be x1 or x2. What should come here? x1, x2 or x3, x4? In what terms should I write? x1, x2. Okay, good. So x1 equation, you will tell me. x2 equation, Kumar will tell me. x1 equation, yes, I told you. Tell me what will be the maximum? What? Which one? x2 is? Minus 1 by 2. I have the correct thing written there. So you can't.
x4 minus x3 plus 1. x4 minus x3 plus 1. Plus 1. So minus x2.
Okay, now with this, you can tell me x1 and you can tell me the objective function. Two of you got saved because you are on the other side, you are on the darker side of the classroom. So here you just put x2, right? What do you want to write x1, right? So you just put.
x3 plus x2 minus 3.
You are not supposed to answer. So you have x1, you have x2 in terms of x3 and x4. Just substitute it here, right? Similarly, here in place of x2, you will just substitute this equation to give me the objective function. So what is the objective function and what is x1? So Anya, do you have the objective function? Yes.
I have x1 and x2.
So I want objective function in terms of x3 and x4. That means I have to replace x2. This was the hardest part, which you already did. Not hard part, but but using this, you can substitute here and give me x1 and max.
5 minus 3x4 minus x3 by 2.
Sorry, 5 by 2,
Minus 3x4 minus x3
3x4.
minus x3.
This? Everyone agrees? This is correct. I don't know about x4.
2 minus 2x4 plus.
Are you telling me x1?
Oh no, max.
You are changing your answer here?
It's correct. Okay,
It's correct? It's correct. Okay. Okay. What about x1?
3
No, you don't tell x1.
minus half x3
Hmm.
minus 3 by 2 x4
Hmm.
plus 1.
Okay. And now, what do you know for
That's not correct.
which one? x1?
Yeah.
Minus x3 minus x2 minus the constant should be 3 by 2, right?
right? So the important lesson here is that for this solution, this basic feasible solution, the value is optimal first, but what is the value? 5 by 2 because x4 is 0 and x3 is 0, right? So your optimal is written here. Cool. Now question is that the best? And that is easy to see because x4 and x3 are 0. As soon as you increase it, it is going to go down. So now it is in the form where it is easy to see that 5 by 2 is right. Let's look at what was the outcome, right? Start with the BFS, check if it is optimal. If not, find a variable to include. Find a variable to leave, get another BFS, right? Even though we did this simple example, some of the steps now we know can be done. Can you tell me, do we know how to start with the BFS? No. In this case, we were actually very lucky that we had x3 and x4, right? For example, if we had a greater than equal to thing, then we would have a minus sign and then we would not, right? So we were lucky to start with a BFS. That's not going to happen always. So there were equalities. In this case, we always had slack variable which we could put at BFS. So this we still don't know. But once we do this, we can always express our objective function in terms of non-basic variables. And then it is easy to check if it is optimal or not. So this now we know how to check whether it is optimal or not. If there is some coefficient in the objective function which is positive, then we are not at optimal. Otherwise we are. Again, this is for maximization, you can do it for minimization, right? Now, find a variable to include, pick any variable whose coefficient is positive. Fine. Find a variable to leave. This I kind of overlooked. So, what happened is, now here x2 goes inside, right? Now, x2 went inside and I could increase x2 because this was 1. What if this was 0? This is actually the case where multiple BFSs give rise to the same vertex. And since it is the same vertex, the optimal value is the same at all these points. So there is a chance that you keep rotating in under those BFSs. You are at the same vertex, but your algorithm is rotating in those BFSs. Okay, so this is the case when you have your size of S is actually less than M. So there are in your BFS the things which are 0. So let me write it. What will happen in that case is so you have 2, 1, 3. And let's say M is equal to 4, correct? Now, these are linearly independent. Now, it might happen that I can add this column also or this column also and still keep it as linearly independent. Then that means I have two BFSs. One is 1, 2, 3, 4, 1, 2, 3, 4. Another BFS is 1, 2, 3, 5. Both the BFSs correspond to the same solution X. And then potentially it could happen in your algorithm, you go from here to here, then from here to here. And what is the guarantee that we don't get into this cycle? This is a small trivial technicality, not small, but a technicality. This has to be taken care of. So we don't know. We know how to remove, but not accept.
But why would we go from 4 to 5? We go in the optimal direction, right? Then we will see
It might be that the coefficient of this is positive. Like here, there was only one coefficient which was positive. There can be 10 coefficients which are positive, or there is just one coefficient which is positive, but that positive takes you there, right? So that would happen if this constant comes out to be 0.
But they finally will give the same vertex, right?
Yes. But our algorithm will say that, oh, I have removed x4 and put in x5.
So we do it arbitrarily, we do not check the optimal variable to remove.
So, yes, so this, okay, good. So, some idea that what happens if there are multiple coefficients which are positive here. At this point, I have said pick any. Agreed? But there is a way to say that, oh, I will, if there are 5 coefficients which are positive, I will take a particular one, and in that case, we will not get stuck in this. But the way I have described it is, look at the objective function. If the coefficient is positive, that's the one to get included. Right? So, so my point here is that there are 2 directions, there are multiple directions. How do I know? This also does not decrease the value, this also does not decrease the value.
You can check both.
But it might become expensive slowly, no?
But we only do one computation, right? We for one vertex we check all the edges, we go to that edge, then we do not.
The number of, okay,
But we are not checking that we have found the same vertex, right?
yeah, so there is a way to select so that you don't get into the same vertex. That's the problem. Sorry, I probably didn't answer your question.
So if we check all the edges from this node and we go to the one which has the most increase, which has the most optimal thing.
Okay, what if you are stuck here? This is the point where the increase happens. 1, 2, 3, this is a cycle, these are same BFSs, but the increase you have to go from here, not from here. So from at this point, every direction you are not increasing, you are staying the same. You just Google degeneracy in linear program, they will give an example where this happens. Yes, but what I am saying is that now you are visualizing it in terms of vertices. Don't visualize in terms of vertices. In terms of BFS, this is the structure. You have these 4 BFSs, they are connected to each other. You can only move between them. Like at least from this vertex, you can go to this BFS. But from this BFS, there is a way to improve the solution. So you have to be moving from here. You cannot stay here. But from here, in every direction, you don't increase. It's the same. So which direction to increase? Okay. So there is a way in which you don't come back to this. And that depends on time, whether I will do it or not, but yeah. So this is partially we have seen, partially we have not seen. And then, this is also fine. Okay. So next time, I will formalize this in terms of the matrices, and then we will see these two, this degeneracy and this step. That will complete our simplex algorithm distribution. So once again, more intuition now, we have made it more complete. Then still some points, we will again see, make it complete. Okay, sorry for taking 5 more minutes. Any questions? I am here, so thank you.